Predicting products of chemical reactions. Such a fun topic. I absolutely love doing this, so I hope you're going to enjoy it as much as I do. And the key idea here, actually, it's not guesswork. When you can recognize patterns, types of reactions, prediction here becomes quite logical. So let's dive in. Our first reaction, calcium metal with some water. So this is a single displacement reaction. You might know of it as a replacement reaction. And the calcium ions, they're a 2+ ion, and the water, that's going to split into hydrogen ions and hydroxide ions. So if you know anything about electrolysis, when you split water, electrolysis, lysis just means splitting with electricity. So they're the 2 ions that we would get, and therefore we're going to get calcium hydroxide. So calcium hydroxide, and as we said, that is a 2+, that's a minus ion. So the charges, they're going to cross over, and that means that 2 would be there, and this 1, which is assumed, that would be there, but we wouldn't write the 1. But the 2, now we've got to put this hydroxide ion in a bracket. Let's remove that lot, pop a bracket there, and the 2 goes there. And then also, because it is the reaction of a group 2 metal with water, we will also get some hydrogen gas. So plus H2. And then if we want to, we can go ahead and balance the equations, but we're predicting the products of chemical reactions. Let's not worry about that. Let's just move straight on to the next one. Hydrochloric acid plus some sodium carbonate. This is a classic neutralisation reaction, and we have hydrogen and chloride ions, and then we have sodium ions and the carbonate ion. We'll make a note of them. That would give us hydrogen ions, chloride ions. Both have a single charge. Hydrogen is 1+, chloride is 1-. Sodium, that produces a 1+ ion as well. Then the carbonate ion, which is CO3 2-. So we've got a neutralisation reaction. The products will be salt and water, but also we've got a little extra bit here. We've got some carbon, and that means we're going to have some carbon dioxide. So what will our salt be? Well, nearly always whenever we're dealing with hydrochloric acid and some sodium, we've got chlorine and sodium there. Sodium chloride, there's our common table salt. So that's NaCl. If we look at the charges, we know sodium is a positive 1+ ion, chlorine is a 1- charge. So it's a 1-to-1 ratio. We can leave it just as that. Remove the charges. We don't keep the charges in the final formula. I'm just popping them on for us so we can work through them together. So there's our salt, plus we need our water, so our H2O, and then we have our carbon dioxide. Next we have sodium phosphate and calcium chloride. This looks like it's going to be a double displacement reaction. And if you want to go ahead and predict the products, I'll go ahead and solve it in 3, 2, 1. Oh, I should say predict it. I'll go ahead and predict it in 3, 2, 1. So again, let's separate the ions. Sodium, 1+ ion. With the 3 here, you see we've got 3 sodiums. There, that should give us a clue on what the charge on the phosphate ion will be, because you need 3 sodiums for 1 phosphate, so that tells us the phosphate ion is a 3- ion. And then calcium chloride, calcium is in group 2, so that is a 2+ ion. And again, the ratio of 2 to 1, that tells us the chloride ion is a 1-, which we should really know at this level. It's in group 7, the halogens needs 1 electron. So our products, we've got sodium chloride again, and as we saw from that one there, it's a 1-to-1 ratio, so that's fine. We can also see here, look, 1 to 1, and then we're going to end up with calcium phosphate. So calcium, look, it's a 2+ ion, phosphate 3-. I'm going to pop this in a bracket, and then look, we have a 2 on the calcium and a 3 on the phosphate ion. If we use the crisscross method, the 3 was here, the 2 was there, that's going to go there, become a 3, that one's going to go there, become a 2, and so we have CO3PO4 2. Get rid of the mess. Now there's one other thing that's quite interesting about this reaction, and that is calcium phosphate is actually insoluble. So in this reaction, it will form a solid precipitate. I haven't popped state symbols on this, but if I was to, I would say AQ here, aqueous, This one's aqueous. So is that. I would do that. I would say a solid. So this reaction is not only a double displacement reaction, it's also a precipitation reaction. And then finally, we've got this one here. So C6H12O6 plus O2. The first thing I'm looking at here is I've got carbon and hydrogen. I've got some form of fuel. It's not a hydrocarbon because we've got some oxygens there as well. So this molecule, hopefully you've spotted it, is actually glucose. And glucose burning in oxygen, in enough oxygen, that's a reaction that happens in nearly every cell in our body, and that's the respiration reaction. And the products of all fuels burning in oxygen and combustion reaction, the products are always carbon dioxide and water when there's enough oxygen. If it's incomplete, we get carbon monoxide, but unless they state that it's incomplete, we must assume that it's complete. Incomplete will mostly just have an O. It won't be O2. So that's kind of your hint that it's incomplete. But this is complete, so our products, carbon dioxide plus water. And this is Sally from Learn Page by Page. Thank you so much for watching. I'll see you next time.